Hi, dear students. Good morning, and welcome back to our new class once again. As we are dealing with our transformers, and we made in last class we have just checked out the single phase transformer, that is single step or two step, three step, four type transformers where we have drawn. So in today's class, we have to go for further. In previous practical session, it was a very good session as most of the students were drawn very beautifully, and according to dimensions, we have drawn this single step, two step, and three step transformer. And as we are dealing with our chapter 2 and part 2 session, and in today's class, we are going to have a detailed and single phase core transform, that is we are going to check out the plane and elevation. And basically, if you have a books, kindly take them, but because as this theory class would leading you to how to draw a single phase transformer of 250 kVA or 220 by 11 kV, of that is full plane elevation. And so here I have just gone through a system, just you just look at it, so which will, with the help of the class, we will check out the upcoming session. So just read through the thing. The first thing, if you have seen the clearly, draw the following views of a single phase transformer of 250 kV and 5 kVA transformer. We have to draw the full plane elevation, and the given, if you check out the question over here, it's in single step core. The main important aspect is it is a single step core. The diameter of a circumference circle or the core is given as a 24 centimeters, and distance between two center of the core is 42 centimeters, and inside diameter is 25 centimeters and outside. So in previous class, as when we are dealing particularly about this so-called single step core transformer, we have seen the outer transformer, that is HT winding and LT winding, consist of two. Let us see now, before starting the diameter, let us see the question. Across the question, how many diameters do we really have in this particular question? See, one, diameter of a core. 2, this is the distance between center of the core, just leave it there. There is an inside diameter and outside diameter, that is LT winding. And HT winding, there is an inside HT coil and outside HT coil. Now if you check out the properly, we have approximately 1 2 3 4 5 circles, means that the given data consists of 5 circles. So how we are going to draw these 5 circles? I have taken the help of diagram. Now let's see. The outer side diameter consists of what? Inside diameter consists of what? Now let us see. Let us try to draw the plane elevation, and at the same time how to develop by using single core. Now let us see that things. Okay. Now see here the dimensions which are given. So how we are going to draw that particular thing, and how did we have developed plane elevation, and at the same time a full scale section elevation, what we have drawn so far. And let us check out in upcoming total session how we have took this thing. So first, main important, the given diameter, if you check and see the question properly, you have the transformer, a detailed, this is a single step core, and the diameter is given. Now, how to draw a single step core? Let us see. Now, when in previous class, I have shown you that if I am using a single step core, we have to use 0.71 diameter into core, that is core is 24 centimeters, and the dimension which is required is 0.71 dia. So the core is multiplied where we get the, what is the step, what is the step do we have. So we will get that by taking the dimensions given in circumference circle, that is core of a transformer, into 0.71, which leaves us. Now what are the rest of the windings? So first of all, we will have to develop the elevation. So we will, by using that data, we will try to draw the single core. And now here you can see, by using that thing, whatever the dimensions we have given for us, and based on it we will just try to develop the below part, and later on we will try to what do you say, we'll try to develop the elevation, that is full scale elevation part. Now how did we saw, or how did we try to develop? By using drafter, and this is, as this has been developed in an just an we are using Microsoft uh, word to give you an explanation regarding this. Now let us see. Now here we have full elevation. This is developed, the blue color which you are able to see is completely taken by the violet, which is of HT winding. These are the extensions of the core which is given below plane, and based on it we have extend the core. Now what you do, what we have to do is, I'll just check out the elevations, and after looking properly towards this complete diagram, what I will do is, I, with the help of pen and scale, will try to enhance how we can draw a single phase elevation by given data. Okay, now let us see here. First of all, I am taking the core with the number of diameters what they have given to us. They are approximately 5 diameters. The first one is outside diameter of an HT, inside diameter of an HT, outside diameter of an HT, that we, as we have discussed. So first of all, we have to take a pro circuit, that is compass, and we have to draw, as this is show, I'm showing in WordPad, but first of all this has to be drawn with the help of compass by using drafter. So first of all, let us see. Let us take 2 points and draw the distance between two centers, and first of all we'll try to develop the circles. So first thing what we are going to do is, here in this particular session, in this particular area, the first of all we will try to draw the outermost. I have taken the outermost scale, pardon. So first of all, the first, after drawing that, we I'm taking the extension. First of all, I'm trying to develop the elevation, front elevation. So first of all, I'm taking the extension of an HT winding. I have tried to take and state perpendicular lines by using drafter, and afterwards this is in center of a core, that is given with the help of 0.71 centimeters. Again, by using, I'm extending that particular thing to an height of a yoke. The height of a yoke, you can see it in given data. Later on we can expand from certain one base point, and then joining those two things, this will become yoke. And second one, from a particular point, let us try to check out what is the distance between the 2 points. The distance between two yoke heights should be given as this you are going to develop manually. uh, so when you are developing it manually, this will be a different thing. So first of all, as it becomes, what is as we are explaining theoretically and practically, it becomes little bit slight differences when you are checking, when you are drawing, and when you are checking this mm, what do you say uh, take drafter. Again, when we draw it practically, it becomes little bit different. I'm just developing it by using AutoCAD 2010 module. And in 2010 module, just if you want to have, just download it. And it's a free version is there or not, I don't know. So the dimension given, so after that, this is a total height of an yoke, where we are developing the total height of an yoke. What is the distance given? So After what, again I am extending towards the next side. The next side, the distance between should be same as per the given data. So here again I am extending that thing. So first of all, the total height of an winding, if you take the total height of a winding in a given data, there you can see the winding has certain distance. If you check out the question again, once again you check out that, based on that I have given the height of an windings on both sides and took the distances. These things you just draw as per the given data or the dimensions given in a particular question. So after completing that particular thing, what I'm going to do is the particular total place. If you take the center and if you see, just check out the distances. Now try to extend each and every circle elevation in a same manner. That is, if when you're extending a particular thing, just make make sure that, see, this is an HT winding, LT winding. So now let us develop the core. Now what I am doing, I am trying to extend each and every bar so that every thickness can be easily drawn, and that particular part. So now you see the extension of an HT winding is been extended on every side, so you also extend accordingly, so until the height of an HT winding. So after that, when we are trying to laminate those things, we can understand clearly until where it has been extended, how we are going to develop the plane or elevation of a single phase transformer. So this is how, where you have to extend clearly. Hmm? And after extending clearly, just check it out, as I'm extending LT windings extensions also. I have used both of them. I'm extending both of the things and the air gap. And after extending all those things, you have to extend on both sides. That is, for every single core on both the ends, you have to extend the same. So two sides, after extending the thing, the height of the linear, just I'm just copying this object to make sure that certain things. Why? Because I have to have only, and what pencils do you have to use, what type of HT pencil, HB pencil, when you're drawing this we are going to check that. Okay, that is a total HT winding. This has to be drawn by using two HB pencil itself. Why? Because the total elevation which we are presenting over here is in the form of HB pencil, and dotted lines has to be extended. When you are trying to extend, use 2H pencil itself. And after extending 2H pencil, try to utilize HB pencil. And for for hatching purpose is generally, why we use hatching means to show, indicate what do you say, what is the plane, sectional plane, and what we are projecting in elevation, both should have same similarities. So for that purpose, the hatching which is shown in HT winding should be matching with the in elevation plane where we are drawing, showing you right now. That this is the backlight rings where we are extending. The backlight rings dimensions is given, that will be 2 centimeters, or the as per given data you have to extend both of them, and you have to show the hatchings, the main difference. And see here, and for an understanding purpose, these are the backlight rings. For your understanding, the same thing which I have developed over here and I'm showing you. So when you're giving the hatching backlight rings, after completing backlight, the same thing you can make sure that you're extending on all the ends. That things has to be drawn physically. So after drawing physically, just I'm adding the hatching lines for the understanding purpose. But you have to, while you're drawing on your screen, you have to take the help of hatchings, draw the hatchings, and the hatching should match, that is in elevation plane and in sectional elevation plane and plane, both of them should match each other. I have done hatching over here, but this has to be drawn physically, where you have to use only HB pencils to show these hatchings. So in system we am doing, but it takes a lot of time. It's a time consuming thing, but so you have to make sure that you have drawn in a very comfortable manner. So now after completing the hatching, so after completing this hatching, what you do is take that this has to be extended for every particular areas. Now see here the extensions has been done for LT winding and HT winding. It's the total height of an winding. The winding should match with that, and the backlight rings will be above winding. Okay. Now after completing this particular session, now the center points has been taken, that these center points are the center points, the circumference distance between two circumferences, that will be shown as a distance between two circumferences. So the same, you what you do is you have to extend on both ends. As I said, in as you are drawing manually, this has to be extended on both sides, that is plane, sectional plane, which we are drawing below. And after that, see here in this I am showing you clearly, it is having extensions 1 2 3, and after extending that particular model, I have extended on both ends, but you have to draw it in manually, so it takes a lot of consuming so time. So after developing these two things, try to, these are the ducts which are given for you. These ducts, it comes from the center point of an core. You take center point as a reference. For that center points, draw a dotted line, and on that particular dotted line, you just take this particular things of a single phase elevation. So now what we are going to do is, you have checked it manually. Now I'm just giving you with the help of drafter. Now what we will do is, with the help of a sheet, I'll try to draw one a small, for a reference purpose, I'll draw one small single phase elevation, how we are going to do, and based on that you just practice the session. Okay. This was what is it, this was about sectional elevation. Now let us look at how we can draw this particular thing in on a pens on with the help of drafter. Now see here, first of all, the approximately how many diameters they have given to us. If you see, there is an, if I am just put it on a paper for an understanding purpose, I am taking the with the help of paper. Now you see, I am having, yeah, I am having diameters of an LT diameter, that is D1, that is inner and outer diameter, and HT winding also I have inner and at the same time outer diameter. Okay. And afterwards circumference of a circle will be given for you, that is core diameter. Totally 5 diameters we got. And the main importance is distance between two circles will be given. This is one of the important. And the height of the yoke, the of yoke height of an yoke will be given for you. And second thing is, after completion of a height of a yoke, number of backlight rings, that is what will be backlight rings. And second one is the height of winding, that is height of an winding will be given. So by providing this data, what we have to do is, we have to show, first thing is the distance between two centers. So what we are doing is, the distance between two centers is some x value that will be given on your paper. So after that, by utilizing compass, what you do is, first the circumference is given as a diameter. So convert it into radius divided by 2, you will get a radius r. Okay, in radius you find out the radius, and after taking the radius, draw the first circle, circle 1. This will become the core of a circle. And after that, what is an inner? Here you have HT winding is given two dimensions, that is inner and outer. LT is given as two. Take on both sides again, take the same circle, friends, and draw the two parts, that is first circle, that is LT winding, inner diameter, and inner inner winding and outer diameter of an inner winding. By using same circumstances, you just take a drafter and draw, and after completing and draw the exterior, that is HT winding, and you have drawn the HT winding drawing. And after again taking the compass, draw the HT winding outer post and HT winding outer part. If you see here, this is a rough diagram. Don't make sure that this is a as we have, when we have a practical session, we will draw it in you have to draw the elevate hatchings in 45 degrees by the help of drafter. Place it in a drafter and make sure that the hatching is same on both sides. As why? Because this is an HT and this is an LT. Okay, after completion, take the extensions from it again. First component, as this is a single step, as we are drawing in a single step, what will take diameter 0.71 into the core is given. What will the core will be the some x values, that is 24. Some value will get. After that, try to develop, put it on a scale, just extend where you get this particular x value. Okay, now after completion of this value, this is in center, and you have a step core, that is single step core. Just try to make sure that keep your drafter in an L shape, that is exactly 90 degrees. Your drafter should be placing like this, and place over here in that particular. Try to extend some extensions with the help of 2H pencil. Okay, draw that with the help of 2H pencils only. Try to extend the hatchings with the help of hatchings. Now after extending these things, take one base, and based on certain particular point, from here, as you seen in AutoCAD, from here you just take the height of an LT winding, that is total what is the winding cut. So here one more most important thing is, when you are taking this particular thing, you make sure that this particular center of a yoke is been calculated. Here the center of the core, the height of a yoke will be decided. This is the height of a winding, this is a complete total box of unwinding, but these center points, these two center points will give you the height of an yoke. Okay, this is how you will develop the um, this is how we'll try to develop the things. So now if you just look at the particular thing, that thing we have to develop here. Now see, now what we are doing is, here what we will try to develop over here is just after completing that particular area, we'll just to see for an understanding purpose I am showing you. And after certain secondary, you make sure that this is been drawn carefully by you guys, and the hatching is done properly. And after hatching is done, what we will do is, after completion of hatching, we'll try to extend, hmm? we'll try to extend the things. This is how you have to draw the sectional elevation. Okay, now first of all, we have taken for an understanding purpose, just I am showing you. Now this a particular point, we have drawn the outermost circles, and for this extension, as this is the pure extension of that, and this is unwinding, and the total HT winding and LT winding height of a winding is given in this particular thing. So in practical session, now I expect you to draw this particular single phase, single core plane and elevation questions. You have to draw a first one plane and second one elevation. In next class, we will try to develop the same thing for three phase. How we are going to develop in three phase? In during first class, when we have seen that thing, three phase, how we are going to draw that thing, we will try to learn in deep. Okay. And hope that this class has been done. Just I'll give you an assignment. What you make sure is I'm giving you one question, make a note down of it, and just I'll read it for you. Just you take the paper and pen. I'll just read it out for you, so that you can make a note and draw it accordingly. This is a single phase transformer. Draw the plane of a single phase 230 volt, 230 by 110 volts, 5 kVA single step transformer. The given data is like this: the core is of a single step, diameter of a circle is 7.5 centimeters. The distance between the center of the course is 15 centimeters. Now the height of a yoke is 8 centimeters, as we discussed in shown in the video. Now LT winding. The outer diameter of an LT coil is 9 centimeters. Inner diameter of an LT coil is 8.7 centimeters. Height of an LT winding is 23 centimeters. Number of turns per limb is 50. Here there we have shown the hatching. In hatching you have to reproduce the 50 dimensions as seen. So the LT winding, the outer diameter of an HT coil is 13 centimeters. Now just I'll give you for bifurcation. You just take a screenshot of it, which will help you to understand the question. So here is that particular question. Just to make note of it. Here we have that. If you take the screenshot of it, we can go to the next class. So hope that in this class we have completed our single phase plane elevation. I'm giving you the single phase stepped core type data, and by using this, just try to develop single phase stepped core dimensions. Okay. And while you're completing, you make sure that the code should be shown progressively. Here I am showing you the model as we have shown in system. I'm just showing you model as per your textbooks. So this is how you are going to develop an elevation of a stepped core transformer. So this was all about your single phase transformer, as we are dealing with your plane elevation, and we have seen with the help of what do you say, with the help of a diagram, we have tried to develop the particular uh, elevation with the help of single phase transform. With the help of AutoCAD we have tried to develop, but the same thing you have to draw it by using sheet on sheet, by using drafter. So I hope that this class will make you mm, understand neatly of next class also. So be prepared for your next class. In next class we'll try to learn about your chapter 2 third part, that is three phase transformer. And in three phase transformer we are going to deal how a three phase stepped core is developed. And after learning about core type, we'll try to develop a three phase elevation. So this elevation also will help you to come across the things. So let's see what best things, what so far we can do uh, in electrical engineering drawing. So let us learn. And I have given you my description below. In description you can just look at the course. In coming class we will see how the step course is been drawn. Okay, how step course can be drawn individually. How scare steps can be drawn, I'll just draw it on a paper and I'll show you. With the help of that, let us complete our next class. Okay, hope you have understood it. Thank you so much, and let's meet in next class. Thank you.